Hi everyone. In today's section, we are going to explore the proportional relationship between circular sectors and the entire circle. By the end of this lesson, you will be able to find the arc length and the area of a sector, given a specific central angle, whether expressed in degrees or radians, all without memorizing any new formulas. Additionally, we will learn how to convert between these two units, likewise without any new formulas. My main focus is on grasping the fundamental logic rather than relying on rote memorization. So here is a circle with radius r. So the central angle of the entire circle will be 360 degrees. Its arc length will be 2 pi r, just the circumference 2 pi r. Its area will be pi r squared. And for a semicircle, let's draw a semicircle here. Since it's semicircle, so the central angle will be 1/2 of the 160 degree, 360 degree equals 180 degree, and its arc length will be just 1/2 of the circumference will be c times 1/2 equals to pi r, and the area will be just 1/2 of the area equals to pi r squared over 2. And for quarter, we know that the quarter means 1/4 of a circle. So its central angle will be 360 degree times 1/4 equals 90 degree. And the arc length will be circumference times 1/4 equals to pi r over 2. And the area will be also 1/4 of the circle, that equals to pi r squared over 4. And if it is 1/8 of a circle, 1/8 of a circle, this part. So the central angle will be 45 degree. That will be 360 times by 1/8 equals to 45 degree. And the arc length will be circumference times by 1/8 equals to pi r over 4. And the area will be 1/8 of the area equals to pi r squared over 4. So based on this table, we can see that it's clear that a sector maintains a constant proportional relationship with the entire circle, whether measured by its central angle, its arc length, or its area. Take semicircle for example. Since it's a semicircle, so its central angle will be 1/2 of 360 degree. Its arc length will be 1/2 of a circumference. Its area will also be 1/2 of the area of the whole circle. So imagine we have 3 different ways to look at this same slice of the circle. Each ratio is just a different perspective on the same proportionality. The angle perspective, the ratio of our central angle to the full 360 degree. Let me write this on the screen. Central angle over 360 degree. And equals to the arc length over, I use c to represent the circumference of the whole circle, and the area of the arc, I use small as means a small, means the area of the arc over the area of the whole circle. AC, I use AC means the whole circle. These 3 ratios should be equivalent because we know that a sector maintains a constant proportional relationship with the entire circle. These 3 ratios just represent this constant relation, proportional relationship in angle perspective, in arc length perspective, in area perspective. Okay. Basically, they represent the sector over the whole circle, entire circle. Okay. So with this equivalent, with this proportion, we can solve different kinds of questions about the circular. Here is an example. A ball is rolling in a circular path that has a radius of 10 inches. As shown in the accompanying diagram, what distance has the ball rolled when the subtended arc is 54 degrees? Express your answer to the nearest hundredth of an inch. Okay, so basically here, we know the center of the angle, 54 degrees. And we're trying to find the arc of the arc length here. So it's about central angle here and arc length here. So we choose these two equivalent ratio to make an equation. Okay, first we need to find, we know that the central angle is 54. Okay, so 4 over 360. And then that should equals to the arc length. Okay, we set it as x. And the circumference will be 2 pi r, which will be 2 times pi times radius 10. And then solve this equation, we can find the arc length. All right, this is so easy. And what if the question is about the areas? What is the area of this sector? So if this area of the sector, so we just change this equation. We choose these two, area and the central angle. So we make an equation. You have 54 over 360 equals to this area. We use AS to represent the area of the arc. And the denominator will be pi r squared, which will be pi times 100, or 10 squared is 100. So solve this equation, you can find the area. So no formulas, no new formulas. It's just about equations, equivalent ratios. And then we move forward to the correlation between the measure for angle, measure for degree, and the radians. So we use a unit circle. What is a unit circle? The radius equals 1. A circle with radius equals 1, we call this circle as a unit circle, unit 1. Okay, so let this central angle be 60 degree or 45 degree. Okay, here 45 degree. So what is the length of the arc? According to our equivalent ratio here, we choose this one and this one to find arc length. So the central angle is 45 degree over 360 degree. That's equals to the arc length x here over circumference will be 2 pi r. So here r is 1, so it's 2 pi. All right. Okay, we simplify the left side here. Left side is 1 over 8. So we write this x over 2 pi equals to 1 over 8. So x equal both side times by 2 pi. Okay, so it'd be 2 pi over 8, and then simplify again equals to pi over 4. So here arc length here is pi over 4. All right. So people defined this central angle with degree 45 degree, and we can say it is pi over 4. We can also say it is pi over 4 radians. Okay, so we can write this on. We can write this. Okay, 45 degree equals to pi over 4. Oh, remember, here's radians. You cannot never write 45 degree equals to pi over 4. It's always pi over 4 radians. Okay, because we know that pi is 3.14 divided by 4 will not equal to 45 degree. Okay, it's radians. It's radian. So pi over 4 radians represent 45 degree, and 45 degree is equivalent to pi over 4 radians. But here, what if we want the central angle of the sector be 360 degree, which means that it's a whole circle. So what is the corresponding measure of radian? So here we set 360 degree. We choose here means the central angle is 360 degree for a given sector, and it's over 360 degree. That should be equal to the arc length here, over 2 pi. Okay, again, numerator means the sector. It's represent the sector. The denominator represent the entire circle. Okay, entire circle. So here x should equal to 2 pi, which means 360 degree is the whole circle. 360 degree is equal to 2 pi radians. Okay, so this is a relationship between measure of angle and the radian. So as you can see that just like 360 degree central angle means an arc is a whole circle, means a sector is a whole circle, so that 2 pi radians also represent, okay, 2 pi here means 2 pi radians, 2 pi radian also represent an entire circle. So the ratio of the sector in radian, I use sector radian to 2 pi radian also represent the ratio of the sector to the entire circle. So we extended this proportion to 1, 2, 3, 4, 4 equivalent ratio. These 4 equivalent ratio illustrate the same constant relationship between a certain sector and the entire circle. And here, for the sector radian, we may use a theta to represent this. Okay, here I wrote theta. Okay, that means it's a sector radian. All right, it's a theta. All right, we choose these two ratio. We choose these two ratio to make an equation. Arc length over circumference, that equals to 2 pi r. Okay, circumference equals 2 pi r. That should equal to the theta over 2 pi radian. Okay, so the arc length both sides times by 2 pi r. Okay, so the arc length will be both sides times 2 pi r. So it's theta over 2 pi radians times 2 pi r. Okay, we can simplify here. So arc length, you can see here, equals to theta times radius. Theta here r represents radius. Radius of the circle. Okay, so that is the formula we have in the textbook, right? So I use this equivalent ratio to derive the formula in our textbook. Actually, we can derive many new formula from this fundamental constant proportionality. This is a typical question about measure of angle, arc length, the measure of angle in radian. Okay, so let's read the question together. It says that here is a circle has radius of 12 units. For this circle, which expression incorrectly states the length of the arc intercepted by the given central angle. So let's try. It says the angle equals 120 degrees and the arc length should be 8 pi. Let's try it. So we use this 120 degree to and our ratio, equivalent ratio here to find if the arc length is 8 pi. Okay, now the central angle is 120 degrees, so over 360 degrees equals to arc length, or we use x over c. C here is the circumference, so it's 2 pi r, 2 pi times 12. And then we solve this question. The left side is 1/3. You simplify here, left side is 1/3. So x over 4 pi equals to 1/3. Okay. Oh, sorry, left side is 2 pi times 12. This is 24 pi. 24 pi, x over 24 pi equals 1/3. So x, both sides times by 24 pi. So it's x equals to 24 pi over 3, which equals 8 pi. All right, so the arc length should be 8 pi. It's correct. Okay, question 1 is correct. Now we move on. Question 2. The measure of angle is 6 degrees and the arc length is 72. So it's still about central angle and arc length. We choose these two equivalent ratios. So it's 6 degrees over 360 equals to x over circumference, still 20. Okay, we remember that is 24 pi, 2 pi r, 24 pi. So left side will be 1 over 60. Right side is x over 24 pi. So we both sides times by 24 pi and flip this equation. So x equals to 24 pi over 60. And we simplify it, that will be 12, 2 pi over 5, 2/5 pi. Its arc length is 72, so it's the arc length should be 2 pi over 5. So this is incorrect. The second one is incorrect. All right. And then we move to the third one. It says the angle here is 2/3. Okay, remember here's 2. Okay, pay attention. It's 2/3 radian. All right, it's not about a measure of degree now, so we choose a measure of radians here, and the length of arc. So length of arc is still x. Okay, the circumference is still 2 pi r, which is 24 pi, and the sector theta, it is 2/3, and then over 2 pi. And here some students may confuse it. So we rewrite this right side as 2/3. It's over 2 pi, it's divided by 2 pi, so it's times 1 over 2 pi. All right? And you simplify the left side, which will be the right side. It should be simplified. It's 1 over 3 pi. So x equals 24 pi. X over 24 pi. So equals 1 over 3 pi. Both sides times 24 pi. So x equals to 24 pi over 3 pi, which should equal to 8. So question 3 is correct. All right, okay. Last one. Last one. Last one, I try to solve this question in a different way, right? We start from here. It says the arc length is 4 pi. We suppose we know that arc length is 4 pi. So we have 4 pi over circumference, which is 24 pi, equals to, now we try to find out what is the radius here? Theta equals to 2 pi radians. Okay, so we simplify the left side. It should be 1 over 6. The right side still theta over 2 pi. And then both sides times by 2 pi. We flip it. 2 pi over 6. So it's pi over 3. All right? So pi over 3 radian. The angle is pi over 3 radians. So it's correct. Okay, so see here, question 2. Option 2 here is incorrect. All right, okay. So let me summarize it. Here we are not trying to memorize any new formulas. We derive this all proportion about 4 different ratios based on the fundamental logic of the constant proportionality about a sector to an entire circle. These 4 ratios and measure of angle in degrees, arc length to circumference, area of a circle to the area of a whole circle, the sector in radians to the 2 pi radian, which is represent the whole circle. They represent the same proportionality in 4 different perspectives. Okay, they are the same. Once you understand this, you will never forget how to solve this kind of question. Thank you. That's all.